Afternoon. I think we'll go ahead and get started, especially in light of the fact of how nice it is outside. I'm sure we don't want to spend any more time trapped in this room than we have to. Want to thank all of you for coming. I'm Leslie Schmidt, the Assistant Vice President for Research here. And like I said, thanks so much for taking time out of your busy schedules here at the beginning of the semester to attend this training. I wanted to give us a quick overview of why we're here and why responsible for conduct research training. It provides all of you with a good foundation to start, to kind of kick off your research work, and some of you are probably farther along down the process than others, but for those undergrads who are just getting started, we'd like to think this gives you a good foundation for your studies. The other reason, a very compelling reason, it's been talked about, this training has been talked about by the federal government for a long time, but they put it into the requirements very recently, as in January of 2010. Both the National Institutes of Health, which has a more rigorous requirement, and the National Science Foundation are requiring at least a minimum level of training. Now, they weren't specific about the type of training, but we're thinking this workshop will meet the National Science Foundation minimal training, and you'll need to work with your faculty members to finalize that and make sure that you have all the training that you need. There's additional online training available for all of you with the city training. We're going to end our workshop today with a discussion of how you access that online training, so just wanted to mention that as well. There's also an additional course being offered this fall for the first time. The faculty member teaching this is Dr. Kristen Intiman, and it's a PHL 491 Research Ethics that'll be available at the graduate and undergraduate level. So if you feel compelled to take this course, I would encourage you to follow up with this as well. I also wanted to mention that it's the PI's and the student's responsibility to verify that you have fulfilled the obligations of the type of responsible conduct or research training that you need. And so while our office has a sign-up sheet in the back and the city training information, once you complete one of those modules, that information does flow back to my office. I just want to mention that if an auditor wanders through and said, have you ever taken this training? It would be really nice if you could say, yes, I did, and here's confirmation that I took it. So just want to mention that as well. And let you know that the NIH specifically requires a minimum of 8 contact hours as opposed to the National Science Foundation, which basically just said, you and your faculty member figure out how much training you need. So we've sort of sifted that out to mean something akin to what we're doing this afternoon. So without much further ado, we'll get started. Does everyone have a handout? We made 60. We weren't really sure how many would get here. Okay, great. And if you could fill out the evaluation forms for us. This is the first time we've offered this type of training, so it would be really helpful for us if you could fill that out, tell us what's helpful information, what's not. Maybe if you're a graduate or an undergraduate, that would be helpful as well. And be sure and sign in, because that's how you're going to get credit for attending today. All right, and we're going to go through a series of speakers, but I'm going to let them introduce themselves because not all of them are here today. So we're going to start with Pam Merrill and Carl Fox. So whichever one of you is starting here. Okay. Just use the arrows. Yep, an arrow. You can corner here if you want.
Okay, well, thank you very much, Leslie. Some of you I saw this morning in the new grad student orientation, so welcome back to MSU. Those of you who are new, also welcome to this course. I think you'll find it extremely informative. I've looked at all the great slides that our speakers have put together, so I'm just going to go through a few brief introductory remarks and give you a tiny bit of background. Pam's going to follow up with research misconduct, a few definitions, and some examples. And then with the time we have left, Pam and I have left, I handed out 4 case studies, and we'll probably try to tackle maybe the first 2 if we have time. We'll just see how it goes. In 2002, the Institute of Medicine issued a report, and I thought this was a particularly important quote. Previous to this time, there's a lot of history behind responsible conduct in research, and I would strongly encourage you to go look at some of that work, particularly the Belmont Report from 1979, some history at the Tuskegee Institute, and some of the things that happened as a result of that activity. But previous to this report, much of the thought process in terms of research and ethics was split. Ethics was over here, and that was one area, one discipline, and research was over here. What happened in 2002 is the Institute of Medicine said, no, absolutely not. These two things go together. They must be combined. And to be a competent researcher, you must understand what it means to not only do the research, but do it in a responsible manner. So it's important that you as researchers understand what the rules are, understand what the impact of your research is, and that you, in fact, have the proper background and the capacity for ethical decision-making. So what is RCR? What is responsible conduct of research? And this definition came from the National Institutes of Health issuance of their new regulation as a practice of scientific investigation with integrity. It involves the awareness and application of established professional norms and ethical principles in the performance of all activities related to scientific research. So essentially the word integrity sort of jumps out at you. And of course, established professional norms. So it is critically important that you understand what is not only acceptable in your profession, but also acceptable from an ethical perspective. These are probably hard to read, but I wanted to give you the actual language from the NIH and from the NSF. And I'm not going to read it to you. I always hate it when people read PowerPoints, and I just did that so you can give me a hard time later. But I just wanted you to know, and you can see the references there, and we'll post this at least on this PowerPoint on our website and probably on OSP's as well, so you can get the fine details. But both agencies are quite specific in what they require and what they're looking for. And it again goes back really to that definition of responsible conduct and research that both NSF and NIH are subscribing to. So there are various components of responsible conduct and research. We're going to cover, I think, all of these today in one form or another, from research misconduct, certainly human and animal welfare and laboratory safety, conflict of interest, and you can read the list as you see as it goes all the way down. Let me just say a little bit about the last one, and that is societal responsibilities. Oftentimes we as scientists, and I can put myself in that camp as a scientist, we often don't think about that part of what we do, that we do have a responsibility to society and how we do our work and how we communicate what we do. So I just want to point that out, that is also part of what it means to be a responsible scientist and to do your research in a responsible manner. These are the 4 case studies, and I'm going to turn it over to Pam. We'll come back to my case studies and we'll look at a couple of those, and I'll tell you about a really fantastic website. So I'll turn it to Pam.
Well, good afternoon to all of you, and again, thanks for giving up this beautiful afternoon. I'm the Associate Legal Counsel here at Montana State University, and therefore, my presentation will be somewhat legalistic. And I want to make you aware of the structure within which ethical conduct of research it takes place, and that structure involves federal regulations, laws, and policies. So I'm going to talk very specifically about the research misconduct policy, which is, let's see if I got the right one here. Which comes from federal regulation, and it comes from Montana State University policy. So that not only is conducting research ethically and responsibly an important thing to do and the right thing to do, but it is also required. So you need to understand what those requirements are. Okay, First, the definition of misconduct in MSU's policy and in regulations includes three things. I'm going to talk about each one of them. The first one is plagiarism. You all know what plagiarism is, and later in the day, you'll learn about that in more detail from Tamara Miller from the library. But you understand what that is, and that is one of the things that will result in research misconduct. The second definition of research misconduct is fabrication. That's, again, very simple, very, very simple concept. It's making up things. And so that is a way to run afoul of the laws and regulations. And then there's falsification. And I don't know, have any of you heard of Mark Hauser? Have any of you read the New York Times in the last couple of weeks? Well, this is a very famous case out of Harvard where a very famous researcher who's a best-selling author, the name of his book is Moral Lives. He teaches, he researches in the area of psychology and the behavior of monkeys. And he is embroiled in a research misconduct allegation situation where other people who were working with him claim that the reactions he measured of monkeys, which supported his thesis that monkeys have very advanced skills, were fabricated. And he is on leave, he's retracting publications, his reputation is destroyed. I'm sure his publishers are wondering if they're ever going to publish anything of his again. So this is an example of a very, very serious result from research misconduct. Research misconduct regulations do not cover authorship disputes, and you're not going to be punished for research misconduct for honest errors or differences of opinion. If you come across any research misconduct in any of your labs, you would report that to your department head or dean, and that in turn would go to the vice president of research who would look into it. And the process for looking into it involves 3 steps. You have to make an initial determination that it's something that you can that's credible enough, meets the definition of research misconduct, etc. Then if that first criteria is met, then you have an inquiry. And the inquiry this is a very formalistic process. The inquiry determines whether or not you go ahead with a really formal process of an investigation. The investigation is detailed procedures. In the case of Mark Hauser at Harvard that I was just talking about, this investigation started 3 years ago, and the thing that started it was students finally saying, you know, he's making this up, and or he's falsifying these results. And the first thing that happened was the university sort of did a SWAT team into his lab and grabbed all of his data, all of his evidence, all of his research results, and sequestered them. And that's what happens in an investigation of this type. Okay, so what happens if you're convicted of it? Well, there's discipline if you're students, student conduct code violation, employee discipline, but more importantly, if you find yourself in a situation where you're guilty of research misconduct, there's a very good chance that your career is ruined, or ruined for a very long time. Okay, Carl's going to go through the examples.
I forgot to introduce myself. I am the Vice Provost for Graduate Education. If you wonder who I am and what am I doing up here, I spent about 25 years in research administration, so I've unfortunately or unfortunately been down the RCR road before. Take like 1 minute and read that first case study. It's called Overwhelmed. And there's a terrific website. I strongly encourage you to look at it if you're at all interested. It's called onlineethics.org. It's been put together by the National Academy of Engineering, and there are somewhere over 450 case studies on that website and a whole bunch of other stuff. It's really interesting. So let's just take a minute and read the first one. Okay, all you speed readers, are you done? What do you think? What do you think about this situation? Any of you as graduate students find yourself in this kind of predicament? Anybody feel that kind of pressure as a student? You know, when we look at some national studies, Duke University has done one recently. 70% of undergraduates admit to having plagiarized work that they've done in the classroom. And we're seeing it, I hate to say this, but we're also seeing it more commonly at the graduate level and in theses and dissertations. So what should this student do? What is this? Is it plagiarism? Is it fabrication, falsification? Somebody help me out here. Plagiarism? Okay. What do you think the student should do? If I had names, boy, I wish I had names. I'd call it somebody. Yes, Cassandra. Yeah, I mean, it's a case where they obviously have to cite the material properly. They need to go back and write it, put it in their own words, cite it if it's obviously, and you'll hear more about this later from, I think Tamara's going to come and talk on plagiarism. But it's an obvious case, and I will tell you that if you don't know, there's a lot of software out there right now that is being used to check for this. I will also warn you that sometimes there are lots of situations where it picks up something, but it may or may not be actually, directly copied from something. But with the internet and with the electronic age we're in, it is easy, and so therefore it often happens. I think we have a few more minutes. Let's take a look at the second case. It's going to take you a little bit longer to read that one, but we have time, so we'll take some time to look at it. I should tell you that some of the cases on this website are real, and some are hypothetical. Looks like most of you got through the bulk of the reading. Okay, so you're Penelope. What are you going to do? All you grad students, what are you going to do? What is it, first of all? What do you think that this is? It's a misconduct. I will give you a clue. That leaves it down to one of three. It's not plagiarism. Falsification, did I hear? Yeah, I'd say that's pretty close to the truth. So, does this ever happen, Leslie? What would you do if you're the student? Where would you go? I see 3 people right here in the front row that might be able to help you out. You can also, if you're a graduate student, certainly come to the Division of Graduate Education, and we can help you work through these situations. I mean, this is a tough one because, you know, it's probably your advisor or, you know, the person that's providing that stipend through their grant funds, but it's clearly an issue, and it's one I think you may find yourself in. I hate to say that, but it is possible. So I'm not going to go through the next 2, but you have them. The next one actually is quite interesting, and there's actually it's not a problem. It's just a way that this particular scientist has set up their lab and has figured out a way to make it clear to all of his students exactly how they will handle authorship. And then the last one I'll just leave to you because I'll let you read that on your own. So do any of you have any questions at this point of either actually Leslie, Pam, or myself in terms of sort of background information on research misconduct, the process that's involved? I will tell you we've had a couple cases in my division of plagiarism by graduate students. And in my 4 years here, that was the first time that had happened. So I hate to admit that, but I just want to say it because it's real and make you aware of it. And we are very concerned about it, let me put it that way. So, questions? You got it down. You're going to be ready for the quiz at the end, right? I think they're in shock. So anyway, that's all for us.
So the down button is down arrow on the keyboard?
On the keyboard. Yeah.
Oh, on the keyboard. Okay, thank you. Great. Well, good afternoon. Thank you for the opportunity to talk to you all about technology transfer. I'm Nick Zelver. I'm the Associate Director of the Technology Transfer Office. We're on the top floor of Montana Hall, and our director is Dr. Rebecca Mahurin. And today I'd like to talk to you, just give you kind of a little crash course of technology transfer, primarily focusing on intellectual property and most specifically patents and how we go about patenting at MSU and how you can be involved in our office if you're involved in developing some new technology. Primarily, I want to focus on how this would affect you, both to comply with the ethics requirements, but also I know some students find it very intriguing on how they might be involved in technology diffusion, commercialization, patent processes, but it's also essentially a growth industry. Patents have grown from about 100,000 a year to 200,000 a year in the last 20 years or so, and that's partly because of the global economy, the complications of developing new technology, the cost of bringing a drug to market could be $1 billion. So there's a lot of reasons why you might be involved in technology transfer, not just at MSU, but as you go forward in your career. So we're a land-grant institution, and as a land-grant institution, our mission is to create and distribute knowledge. And we feel technology transfer fits right into the original mission in the 1880s when land-grant institutions were established. And essentially, we're doing primarily what we've always been doing in the way of transferring technology and moving things out to benefit society. And that's fundamentally the most important thing is graduating students, education, and then employment of students in the workforce with the latest understanding of technology or culture and such is really a primary way of transferring technology and knowledge. Publications. So that's still the primary way we move things forward into the marketplace. But patent and license has really become a new kind of arm of that process. And that's primarily because, a commercial model to kind of understand that is the need for the marketplace, industry specifically, to be able to take risks in developing new technology. As I mentioned, drugs could be $1 billion to bring to market. So a drug company doesn't want to invest that kind of money only to have somebody be able to knock off a generic and compete with them. So building an intellectual property fence around a particular technology has become extremely important. So in many cases, we still want to diffuse technology in the classic ways. Maybe if I give you an example, just a hypothetical example. Let's say the cold science laboratory here developed a new way to analyze snow in a snow pit, and understanding that would be able to predict avalanches and save lives. Well, that would basically be knowledge that wouldn't cost a lot or anything necessary to develop. What's important is to diffuse that knowledge so people know how to read their information from a snow pit. Well, that's probably best done by publication, education, maybe workshops. People in the field understanding, how to read snow measurements. But let's say they came up with some kind of device that you could just point at the snow and say, bam, there's a high avalanche risk here. And it would cost $1 million or millions of dollars for a company to develop that. Well, that might be a case where we would like to see an invention disclosure and look at trying to find a company that would be interested in developing that. So that's kind of why that new arm in the last 20 years or so, new way of doing technology transfer for universities has developed. So there's all kinds of benefits of technology transfer, and I just sort of kind of went over one of the main reasons. But transferring creations to public benefit, fostering relationships with industry, that can be very valuable in bringing additional research to the university, and also providing opportunities for you to get to know company representatives and be able to get jobs in industry later on. Promoting local economic growth is a big mission of ours, and we are not unlike many universities all over the country have been very instrumental in helping promote their local economies by helping to diffuse technology through students, spinning out companies. For example, I think from faculty and students, we probably have 40 or so companies that have started in some way associated with university technology in this area, at least in Montana, primarily this area, providing jobs too for graduates that want to stay here in Bozeman. It also helps serve the faculty that are interested in this process, brings recognition to MSU. Some of the technologies we've had come out of our office that we work with communications at MSU to promote have been some of the highest hits on our website. And then certainly royalty opportunities, which I'll talk about more later. This is somehow the part of this graph didn't come out, but the blue line is our research expenditures per year, and you can see it's grown from 1990 to under 20 million a year to close to 110 million a year in the last year. And the red line is the number of licenses or options to license that we've had coming out of our office. So you can see kind of a proportional growth. The more research that's done at the university, the more opportunities to have technology coming out of the university. So there's been a nice growth. What kinds of intellectual property they are? A lot of these you've heard about. Some of them I'll try to just focus on some you might not be so aware of. But know-how. Oftentimes it's not just a patent that is transferred to a company. In fact, it's very unusual not to have some kind of relationship with a company and to license know-how, the intricacies that you might have developed while you develop technology. In some cases, we've licensed nothing but know-how. Some new device out of a laboratory here that we haven't even patented, but a local company in several cases have seen opportunities for niche markets to develop it. You're probably all pretty familiar with copyrights, but just briefly mention that copyright, everything you write essentially is copyrighted, but there's formal processes through the U.S. Patent Office that you can go through on the copyright process. Trademarks, you see them all the time in terms of name brands. Clorox, for example, it's bleach. You can buy generic bleach anywhere for a lot less money, but people buy Clorox, a name brand product, and that's really what they're selling is their name brand, and it's hugely valuable to them. Trade secrets, we don't do much. Like if you think a recipe for Coca-Cola or something, being a public institution and our emphasis on publications and such, it's not something that works very well at a university. Plant variety protection is very similar to the patent process, but it's geared specifically toward sexually reproduced plants, plant varieties and such. And as I mentioned, patent is the focus of what I mostly talk about. And what is a patent? It's really a negative right, essentially, and we call it that because it's the right to exclude others from making, using, or selling the invention, in this case throughout the U.S., but certainly patents are really a global process now. So throughout the world, it's allowing you to have a monopoly on your invention. It needs to be novel, useful, and non-obvious. By novel, it means to be absolutely new, particularly for international patenting. But even in the U.S., after a year after disclosing something, you can't patent it. So it's disclosed, it's not new anymore. So it needs to be something that's new, useful. If you had some new device to counterfeit money, they would throw it out of the patent office because it theoretically wouldn't be useful. Has to be non-obvious. That's one of the more trickier elements, and that's really what gets considered mostly through the patent process. Somebody skilled in the art has to say, well, that wasn't obvious. And so that gets kind of tricky sometimes, a gray area. But those are the requirements of a patent. So what's patentable? And you're certainly familiar with many things, but processes, how to make a drug, for example, a specific machine, a composition of matter. It doesn't necessarily need to be high-tech. You could have some, process for making soap or something and certainly be patentable. Improvements is a very interesting part of the patent process. That negative right, being able to exclude others, means you could come up with a patent that just was an improvement on something, and somebody that had the original device, let's say you came up with a patent that was some improvement for a cell phone, but you couldn't practice it because you didn't have any patents on the cell phone, and vice versa, the person that or the various companies that have cell phones couldn't practice your technology. It's a very interesting way of kind of forcing some kind of collaboration or cross-licensing, because both of you need each other suddenly if that's going to be part of a cell phone. Interestingly enough, I like to look at statistics that come out just of patents and play around with the search options on the patent office. And I was looking at cell phones in the last about 15 years ago, you could find 0 patents that had anything to do with cellular phones. And now there's about 2% of the 200,000 patents a year have something to do with cell phones. So it's just interesting to me to see how diffusion of technology has become so rapid and so grown so much. I look back to when Alexander Graham Bell invented the telephone, had a patent. It took several years for another patent. And if you took 15 years back then, maybe there'd be 10 patents. So the world's really changed in terms of how rapidly technology develops and the role of intellectual property. Asexually reproduced plants such as grafting, grafted plants, grafted apple tree or such could be patented. Plants and microorganisms which have been genetically altered. Essentially, you can't patent anything that's a natural process. Like a microorganism is natural, but if you take it out of the natural environment and isolate it, it's not natural anymore, essentially, and you might be able to patent it simply by isolating it or genetically altering it. And software is now patentable too. Patent costs extremely high, easily $30,000 or more in the US and over $100,000 worldwide. So we look to licensing or partnering with a company that will pay for patent costs, because we certainly can't afford those kind of costs in most cases. When to file a patent? In the US, you have to file within 1 year of publicly disclosing. As I mentioned, in the rest of the world, it's first to file, and it has to be completely novel. So if it's been disclosed in any way, even through a conversation potentially, you would be barred from patenting. So we generally focus on the international bar of patenting and try to get information or get a patent submitted to the patent office prior to you making a presentation or publishing a paper and that sort of thing. So examples of ways that you could bar the novelty and disclose an invention, certainly publication, including an enabling abstract, seminars, conferences, as I said, essentially a conversation at a cocktail party to somebody outside the university could potentially be a disclosure. And more we get concerned with electronics disclosures, because a lot of times people are publishing, even draft publications often are getting put on the internet right away. So we really like to see invention disclosures come to our office as soon as possible. So protecting intellectual property, certainly the patent is the form of protecting intellectual property, but there's many ways that, or considerations to protect intellectual property that may come before the patent process or in conjunction with the patent process. A big one is a laboratory notebook. I'll discuss more of each one of these in more detail, but confidentiality agreements and material transfer agreements, research agreements, all part of the process. So a laboratory notebook is something that I'd hope all of you would be keeping a laboratory notebook, and it's extremely important to date new conceptions, periodically have it signed by a peer reviewer, and make sure you date entries and such and keep a good record. There's information on the web on how to keep a good laboratory notebook. We can help you with that. The laboratory notebook is MSU property and can be something that MSU will, we certainly want you to have a copy and keep your original laboratory notebook, but be able to ask if there is an issue of inventorship perhaps or something in the process, we might want to be able to ask for that, to look at it, to look at the original and use it in the process. Confidentiality, non-disclosure agreements, secrecy agreements, we probably do more of those than anything else in the office. Basically, that the recipient is agreeing not to disclose information for a certain amount of time. And that's extremely important in the patent process to prove that you haven't disclosed information. And so it allows you to keep that novelty. And we have examples on our website, and all of the confidentiality agreements go through our office and we sign off on them. Material transfer agreements, similar process, but when you're actually receiving or transferring something, an actual material, something that's coming out, rather than just information, oftentimes people ask for it to be destroyed or returned after being used. Again, those need to be signed by our office. And in some ways, a material transfer agreement is a bit like a license, so it gets a little more complicated, but we do a number of those too. Sponsored research agreements, when industry sponsors research at the university, the agreements clearly spell out that we're able to publish. It's extremely important that we can publish, but that we will disclose, if we find an invention, we will disclose that there's an invention and file an invention, a patent on that, potentially with a company helping to fund that. If a student is involved in that process, the student could be considered an inventor. We have testing agreements, which are rather than research agreements that have intellectual property. We might take in materials, they might be unidentified materials that we're just analyzing. And so we don't try to claim any kind of intellectual property that might belong to the company, but we do testing on campus in all kinds of various ways. So if you have an invention, you or your team have an invention, fly it to our office. That is not a public disclosure, but that starts the process. Often we have conversations around it. We're there to help you in that process. And then we file it with often file typically a provisional patent, which allows us a year to file a full patent and try to find a company interested in licensing the technology. Long term, a patent can take up to, well, a biotechnology patent could take 7 years to eventually become a issued patent. So it can be quite a lengthy process, but we'll work with you and through the process, and we typically, we bring in outside attorneys. We use very top attorneys to help us in the process, and we have a very strong relationship with good law offices. Sharing the rewards, students, when they're involved, are considered just like faculty in terms of sharing the rewards. We have as generous of revenue sharing policy as really any university, where 50% of the net, we take a little bit off for our costs, but then the net revenues that come in from licensing, royalties, licensing fees and such, 50% is distributed among the inventors. And MSU retains the ownership of intellectual property that comes out of the university. And if you want to go to the Regents, you can access it through our website, but the Regents, if you're interested in knowing more details about how the policy fits in terms of ownership, students' roles and such, I highly recommend you look at that. And there are some specific areas where students are have opportunities to share in that process, and we have agreements that stipulate how intellectual property is spelled out in such cases as filmmaking, where students are funded by the state for film projects, or a particular company for a film project. There's a specific form for that. Fellowships. A fellowship's a gift. Students that are paying their own way or on fellowships are not, if they are an inventor, have invented something, that's not typically considered university intellectual property, unless maybe a company has been involved in sponsoring some of the work, or they've heavily used MSU equipment and such. There's capstone projects, engineering projects, where companies have contributed a significant amount of in-kind or other kinds of support for the project, and then students are asked to agree that the company will retain their intellectual property. So that's the end of the presentation. We always welcome students to come in and talk to us, even if you are thinking something, you have intellectual property that you think is your own. We'd be glad to talk to you and lead you through the MSU process, or guide you where you might want to go, but we welcome inquiries from students. Thank you very much. Oh, I might mention, I had no idea there were so many inventors that were going to come to this, but so I only maybe have half as many flyers from our office, but I'll leave them in the back for those who want to pick them up. We have a website that you can go to that has information as I've just gone over, and presentations that you can review, and we're available at any time. So thank you.
Just begin.
We're letting people introduce themselves only because they're kind of streaming in.
Okay, we using this? Okay. Okay, I'm Mark Quinn. I'm head of veterinary molecular biology, but I'm also chair of the Institutional Review Board, and our job as the Institutional Review Board is to figure out how to change slides first. Oh, there we go. Okay. Come on. Okay. We'll use the mouse. While you're here at MSU, it's likely that you'll either participate as a subject in human subjects type research, or for many of you, you'll be conducting human subjects research. And so there's sort of very special regulations, and the overall responsibility of the Institutional Review Board is to protect the subject. So we go out of our way to help you as investigators, as researchers, to do your job, but if anything you're doing can affect negatively your subjects, then you're not going to be able to do that research, and we'll work with you to figure out ways to change it. So protecting people who participate in research. One of the things you'll kind of wonder is, why am I even talking to you, especially if you're in social sciences or sociology or other kinds of areas that you might not consider things you do involving humans as research. So research, a participant is anybody you gather information about. And it can be a lot of different things. So things you might not consider, for instance, I don't know if that's a pointer. Is that a pointer? Oh yeah. So information comes from experiments. So we have a lot of research going on that's biomedical in nature and might involve drawing blood. That's a human subject participant. But there are also observations. Now, observation of public behavior falls sort of outside of the category that we would be considering for review, but observation does medical record review. And this last one is really important because there's a lot of research on campus involving surveys. And just because you're doing an anonymous survey using SurveyMonkey that doesn't capture anybody's name or information, that's still considered human subjects research because you're gaining or acquiring information about that subject, and we review that. Fortunately, there are a number of categories for review, and that would review an anonymous survey with a non-sensitive topic would be fairly rapidly reviewed. Maybe it would take less than a day, it'd maybe take an hour to review that type of research. So we just want you to remember that just because we're not doing clinical trials, or you're not drawing blood or actually physically messing with your subject, it doesn't mean it's not human subjects research, and so we don't want to forget that. Because it's sort of brief presentations, I left out all the history behind this, but some years ago, the federal government decided we needed some regulations, and there's a lot of history behind that, but the basic bottom line is that there are actually laws regulating the participation and use of humans in research, and this is the Code of Federal Regulations, and there are a number of items that sort of all skim over, and if you're participating in research, you'll be able to find out a lot more about those because you'll be gaining some more training, and Sandy Sword will talk about that a little bit later toward the end. But informed consent is an important part, and I'll talk a little bit more about that. Training to protect participants. So this is training of the investigator, not the participants. And like I said, we have a new system for training that's sort of universally accepted across the US, and it's a really nice system. You also learn something, so it's not just forcing you to do things. And I also bring this up that we have regulations that this isn't something we at MSU decided that graduate students should suffer a little more, and we'll make them do some extra things if they want to involve humans in their research. This is a federal requirement. If we don't follow it, or if you don't follow it, then we have to report that to the federal agencies, and then research at MSU, at least parts of it, would stop, which would make a lot of angry investigators and professors. So there's also training to protect privacy. So privacy is a major issue, and all research on people must have an IRB approval, and I'll sort of describe briefly about that. So informed consent is probably one of the most important aspects of human subjects research. How many of you have participated in any kind of research project like that? Okay, I just saw in the newspaper you can earn, I think it was $50 to $500, something like that, doing research, acting as a subject for the bioscience laboratories downtown. So there's even opportunities for you if you're interested in that. That likely when you participate, you'll go through what's called a consent process. And the consent process is important because the researcher, you, likely will tell your subjects all about the research. That includes any risks and any benefits, if you're going to make some money, if there's some other kinds of issues. All of those things need to be described, and they all need to be described in language that you would understand. So if you're doing your research in South America, you're going to present your consent form in Spanish or whatever other language. You're not going to present it in English and hope your subjects actually understand what you're talking about. So it's also important for you as a subject that you understand completely. So if you go to the bioscience labs and they're going to put some caustic kind of soap on your hand to see if it works or if it causes problems, then you want to know there is some risk of putting this soap on your hand. And you don't want to find out later that actually your hand melted off and nobody told you about that. So that's the deal. You need to completely inform, and you need to be completely informed. And participants have to have the chance to ask any questions, and you have to make sure. So this is a process that you making sure that they understand completely about the research, and it's your responsibility as researchers, okay? And then you who have served as subjects, you sign the form that says you understood, you were able to ask questions. So what's an institutional review board? Just so you know, we have, so some years ago, I think maybe a couple decades ago or a little longer, the federal government decided they didn't want to enforce human subjects research protections at every university and be actually involved in that process. And so they gave that responsibility to every university that does research with human subjects. And that's what they developed, our local review boards called institutional review boards. There's at least 5 members. They're mixed. They're not all members of one profession, so they're not all scientists. In fact, there have to be some experts appropriate to the research, but at least one non-scientist, and maybe more. And there also has to be at least one member from outside of the institution. And that's so we don't have sort of this conflict where we all want this research done and we make sure it occurs. If we have someone outside, they can give a public perspective on the research, and they can also make sure we don't have this sort of internal conflict when we review that type of research. And the board reviews all research involving human subjects, and then it can approve it, disapprove it, ask for changes. We work with the investigators to help them if they need some help getting the project approvable. And if in the case there are problems, then the review board can also terminate research, although that's very rare and hopefully never would occur with any of this group, right? Because you're the first group learning what you should be doing, right? The rest of us just kind of muddled through. So research involving people, it's important, right? We learn a lot of things. We wouldn't have a lot of the medical devices and treatments that we do, and so we need better programs and treatments. But it's only done with the permission of the participants. That's the whole reason for that informed consent process. And if you go through the training, the city training, you'll see the whole history of why we have an informed consent process. And rules to make it are there to make it safe for the participants. And so I have to emphasize this. It must be approved by the IRB. So you can't sort of decide that it's sort of minimal risk and you're not going to do anything about it, just give us a call and we respond really fast. And we're here to help you, but these guys in the front row will be extremely angry if you're doing your work and not involving any of the review boards like the IRB. Okay, so you're at MSU. Every institution has its own little processes for these sorts of things. The MSU has an IRB webpage. If you can't remember it, which I never can, I just go to the main page and in the little search box type IRB. So Institutional Review Board, and it's the first link that pops up. Several types of protocols. Some are called exempt. Doesn't mean you don't submit anything. It means it's exempt from ongoing review because, so we would review it the first time, approve it, and you could use that protocol indefinitely if it didn't change. So it's exempt from ongoing review. It involves very minimal risk, not sensitive topics, and not minors, okay? Minors may automatically move it into a different category if minors are involved. And some of you guys in the social sciences use minors a lot in your research. Expedited reviews a little faster. Minors can be in this category. And then a full board review if really it's a complex project involving a lot of sensitive things and sensitive subjects. So what you need to do, if you're using humans in your research, you need to complete an IRB protocol application form before you do the research. So by law, we're not allowed to approve research that you did already and then you came to us and said, well, I didn't have time to complete the process or I forgot to complete the process. It puts us and you in a very difficult category. And so we want to completely avoid that. And give us a call if you have any questions whether your research might need review or not, because we can take care of that. Complete the online training. So all investigators are required to do the online training before they can participate as researchers with human subjects, and then submit that to us for review. The exempt process takes about a day or less to review, expedited about a week or a week and a half. In a full board review, we meet once a month, so if on the third Thursday of the month, so if you give it to us the first week of the month, then it's going to take almost a month for that to be reviewed. If you give it to us on the second Thursday of the month, we need a week ahead, then it'll be reviewed in about a week. So you know, it's hard to plan for things ahead of time. We all sort of go on the last minute, but it's really important to plan for this if you want to have human subjects in your research. So, any questions? No, straightforward. Okay. Here's the keyboard, use the mouse.
So good afternoon. We're the last before the break, so we'll hopefully keep you all awake. I'm Chris O'Rourke, and I'm the attending veterinarian for the university as well as the director of the Animal Resources Center, where the small research animals used on campus are housed.
Hi, good afternoon. My name is Mike Babcock, and I'm on the faculty here at MSU, and I'm also the chair of the IACUC committee.
So before we get into the slides, I'm curious how many people have worked with animals in research or plan on or think you may be working with animals in research? So we got maybe a few, not too many. Okay. It's good following Mark because he talked about informed consent for working with humans in research. And when we work with animals in research, they can't give us an informed consent. And so it's interesting, the regulations that were formed for animals used in research were formed before human subject regulations. So the first regulations regarding animals in research was in 1966. So we have been regulated for quite a while with regard to animal use. There were major updates to the regulations in 1985 that are going to affect the people, you guys here who are working with animals, that require that we have training for people working with animals. What we're doing today, if you are going to work with animals, there's a more intensive orientation, a 2-hour hands-on orientation that you will go through. They require adequate veterinary care, the reason I'm here, as well as establishing an IACUC, which stands for the Institutional Animal Care and Use Committee. They require that you look at alternatives. Are there alternatives out there to working with animals? Also, because we have a number of our research projects that are funded through NIH, NIH has additional regulatory requirements in addition to the federal requirements for those of you who are working on NIH grants. And they're very similar. They require the same type of oversight, the training, the adequate veterinary care, the Institutional Animal Care and Use Committee. And we submit those requirements and what we call an assurance or a university promise that we will follow those guidelines. And in addition, Montana State University is accredited through an organization called the ALAC, and ALAC requires above and beyond the federal regulations for the care of animals. To give you an example, the majority of the animals that we have here are mice. The majority of the animals that we work with, probably about 98% are mice. And the regulations are very specific, including things like these animals get 20 fresh air changes in their cage per hour. So I always joke that in our offices we probably get one, but it's very, the oversight is very strong in making sure that the welfare of the animals is taken care of. Let's see. We are reviewed by ALAC. We have a site visit once every 3 years. That'll occur next summer in 2011. And they send 2 external site visitors to review our entire program. And they're usually here a day or often 2 days. The one thing that I always talk about in my orientation at the Animal Resources Center, and really is an important thing to get across, is that research utilizing animals is a privilege, and it is not a right. And it is very important that we follow all of the regulations and guidelines, and above and beyond that. I talk about the letter of the law and then the spirit of the law, because I feel very strongly that the welfare of the animals comes first and foremost. And so that's what I always want to make sure I get across to someone who's new coming in to work at the Animal Resources Center. A single incident of noncompliance can put the entire program of the university at risk. Very similar to what Mark talked about with regard to starting a human subject study before you have approval. Anything that is done without approval or outside of the guidelines can result in very serious consequences. So, and Mike is going to talk a bit about the Animal Care and Use Committee.
Great, thanks, Chris. Well, a lot of this is going to sound familiar, what Mark shared with you about doing research with humans. We have a committee, and I want to just take a few moments, go through a few slides, talk a little bit about what the IACUC committee does. So really we have two primary responsibilities. The first one is to make sure that the animal research that's conducted on this campus, or research that is associated with Montana State University, is performed to the highest standards. And these standards are often set by the funding agencies and regulations. So that's one thing the committee is responsible for. And the other one is really to protect the individual investigators and the institution. Because if the research is not done appropriately or done outside of compliance, then it really puts the university at risk for all kinds of problems. So this is an organizational structure of the IACUC and how it relates to the university. So we have an institutional official, which is Dr. Tom McCoy. We like to call him the go-to-jail guy because according to the regs, if we mess up, he's the one that goes to jail. So we remind him about that every time we meet with him. But then we report directly, or I report directly to Tom as the chair of the IACUC. Dr. O'Rourke, as the attending veterinarian, also reports to Tom. And I guess before I talk about this, I just want to mention the committee. Mark talked a little bit about who's on these committees. And in our case, we actually have 7 voting members on this committee, and they are researchers in various areas on campus. The composition is such that it pretty much fits the types of protocols we get. We have 3 researchers from vet molecular biology. We have some people from ecology because we really deal with a wide spectrum of research projects. We also have some non-voting ex officio members that help the committee with their deliberations. We have representation from biosafety because sometimes the projects involve some biosafety issues. We have a representative from the Office of Sponsored Research because we're required to make sure that the projects that are funded or the protocols that we look at match up nicely with the funded proposals that are out there. And we also have individuals from Safety and Risk Management and the Animal Resource Center. So we bring together a lot of expertise to these discussions to make sure that we're meeting our responsibilities. So here's a quick list of the things that we're responsible for. The protocol review, we do that. We have a meeting once a month, much like Mark's committee, and people will submit protocols, a rather extensive, really lengthy, but important application they need to fill out. We do semi-annual program reviews. We do facility inspections of places where animal research is conducted. We investigate animal concerns. We're really fortunate on this campus. The years that I've been involved with this committee, really we haven't had much of this at all. And we are empowered to suspend animal activities if necessary, but again, this really has not been something we've had to do. We also have some formal reporting and program recommendations, so we meet with Dr. McCoy and provide him with our inspection reports and discuss issues that come up. And that's it for me. I'll turn it back over to Chris.
We were quick. You guys will get a good break, right? This slide is mainly to talk a little bit about, I mentioned animal welfare, and there is a difference between animal welfare and animal rights. And so we always have to be cognizant to some of the animal rights groups that are out there. I just listed 2 of the primary animal rights groups. Oftentimes the HSUS, or the Humane Society of the United States, people don't realize that that's an animal rights group and not affiliated with your local Humane Society. PETA and HSUS are the 2 organizations that most often, although we have not seen too much of this here in Montana, but most often will picket or try and interfere with research that occurs on campuses. The other thing I was going to say is for those of you who do not work with animals in research, if you have an interest in touring the Animal Resources Center, that is available and you can contact me. In that respect, I try and keep an open door policy with regard to that. So I'm happy to meet with people to show you through the facility if you're interested. So with that, any questions? Thanks.
Thank you.
Okay, I want to thank all the speakers and thank everyone for your attention. Looks like we're running a little ahead of schedule, which I'm sure doesn't break everyone's heart. We're going to go ahead and take a 10-minute break. So see you back here at 2:20. That's a good
Okay, in the interest of getting done, I'm going to start a little bit. I'm going to start now. Okay, I'm going to, again, I'm Pam Merrill. I'm the Associate Legal Counsel here at Montana State University. And I'm going to talk to you next about an area of responsible conduct of research that's it's conflict of interest. You know, I've been working with conflicts of interest as one of my areas of responsibility at MSU for 4 years now. And I still have a hard time making my brain understand what a conflict of interest is and what the things are that I need to look for to see whether or not interest can create conflicts. So I want to start out with just a brief discussion to try to help you understand what we're talking about when we talk about a conflict of interest, and particularly as it relates to performing research. And what a conflict of interest is, it's sort of a general definition, is an interest that you might have in something outside your research work or your employment, which has the potential to improperly influence or bias the work that you do or the research that you do. And of course, you are all aware of the classic kinds of conflict of interest that, who is it? Anyway, there's a senator in the Midwest that's always is always inquiring into these potential conflicts of interest in research and federal funding. And the ones he's usually showcasing are the clinical drug trials, where a researcher is performing a clinical drug trial as part of their research, while at the same time, it usually is discovered a couple years later, this researcher was also receiving hundreds of thousands of dollars in consulting fees from the same company that was having their drug tried through his research or her research. So that's the classic conflict of interest. Well, we don't do drug trials at MSU, by and large, that I'm aware of. But nevertheless, we do have lots of instances where interests conflict. And let's go back to Mark Quinn and Chris O'Rourke and the IACUC and the human subjects research. This is something that occurs regularly on this campus, and that is you have a researcher who is proposing to use human subjects for in a particular research project. Well, that researcher is also on the IRB, because we have to have scientists on the IRB that have experience in the research. So the question is, can that researcher be on the IRB and vote and say, oh yeah, I'll approve that protocol, it looks really good to me. That is a classic example of a potential conflict. And in the area of human subjects research, it's a real serious problem if people who have conflicts are part of decisions that oversee their own work. So that's a really good example of the kinds of things that can create a conflict of interest on this campus. And the same is true of the IACUC. And as a result, if there's ever a protocol that comes before the IACUC, for example, related to using animals, the IACUC always removes that person from their discussions and from their vote to determine whether or not that protocol can go forward. So now that's the general philosophical, and now I'm going to spend a few minutes in very, once again, legalistic discussion so you can understand the details of the regulations that cover, because there are detailed regulations that cover conflict of interest in research, and the specific requirements at MSU. And then I'm going to go through some scenarios with you so that you can get a feel for what kinds of things can create conflicts of interest, particularly in research. Okay, once again, there are regulations that cover this, and it is prohibited to have certain kinds of conflicts that are not managed that are related to your research, and these are kind of descriptions of what those conflicts might be. And the regulations in Montana, the Montana State University policy require that if you have any interests that could affect your research or could be affected by your research, you're required to disclose those. And you have to disclose them on your proposal clearance form. When you decide to submit a proposal to somebody, you have to disclose these interests. And the interests that have to be disclosed are significant financial interests, which we will define. And that is anything of value of over $10,000 if you receive income in the sense of consulting fees or any kind of income of $10,000 or greater, or you have a greater than 5% interest in an outside business that could affect or be affected by your research, you must report it. And I will tell you that those, because of that senator that I can't remember his name, because of his interest in this subject, those regulations are being redone, and the threshold amounts are coming down. It will be $5,000, and it will be any interest in a company that could affect or be affected by your research. Okay. Let's continue. You have to disclose that interest on the proposal clearance form, or if you get an interest, if you obtain an interest of that sort after the research begins, you have to immediately disclose. Oh, I better go back. Nepotism is another form of conflict of interest, and there's a state law against that, and there's a policy against that. The nutshell of nepotism is that you are not to be involved in making decisions about your relatives in your work life. It's very simply put. In purchasing, obviously, you're not to be making decisions to purchase or to hire vendors if you have an interest in that vendor. Again, very simple. There's a very special provision in Montana law that I'll just briefly, if I can do it, I'll briefly let you know about. And that is if you ever are an inventor of technology, Nick talked a lot about inventors. We have a lot of inventors. We have a lot of patents. So if you're ever in the position where you're an inventor of technology, it could be very likely that you may want to exploit that technology. This happens on this campus all the time. You're an inventor, and then you say, hey, I could commercialize that. I could make money out of that. So I want to create this company over here outside the university. I want to license that technology from the university. And so can I do that? Well, you couldn't under normal circumstances, except there's a very special law in Montana that allows you to do that if you get Board of Regents approval. So if you ever find yourself in that situation, just come to us, come to me or Technology Transfer, and we'll get that approval for you. Okay, well, that's all the legalistic sorts of things I want to talk about. Now, I'm just going to talk about some scenarios, and I don't really expect that in this audience size I'm going to get a lot of answers, but I'll just talk about these situations that can raise conflicts issues. You're a researcher in a lab, and your father's a consultant. He has his own business, and in fact, the reason you are a researcher in this lab is because your father mentored you along, and you're in a similar field. Well, you've got this research, and your father is perfect. Your father's company, consulting company, is perfect to subcontract research to. The question is, can you do that? And that's a very complicated answer. But very simply put, you can't. You may be able to hire your father's company, but you can't do it, and the decisions around it can't be yours. If you say you're a researcher, but the research is conducted by a very separate, independent PI, and the PI agrees with you, and he's looked at all of these other potential vendors, and he agrees that your father's the best person to do this work. Well, if he makes that decision independent from you, he decides what the compensation's going to be, he negotiates the contract, then that's okay. It's just that you can't do that. So that's another example of conflict of interest. Well, this was made for another. Okay, this is a second scenario. I think I'm going to skip this one now. Okay. Okay, this is kind of like the Board of Regents approval situation I talked about. MSU patents the researcher's invention, as Nick talked about. Well, the same situation happens. This researcher Clever's husband sees this technology and says, you know, I can make some money doing that. So this husband sets up a company and licenses the technology from MSU. Now, do you see a conflict there? It's not the researcher, it's the researcher's husband. Well, you know, y'all have a economic interest in your spouse. You knew that, didn't you? Well, you do. From a legal standpoint and a practical standpoint, you have an economic interest. So yes, that would be a potential conflict. And yes, you would have to disclose it. Could you do it? Well, yeah, you might be able to do it through the process I talked about by getting Board of Regents approval, and we would probably also require a management plan to oversee that potential for conflict. Oh, I don't know where these. Okay. Researcher Bunyan. I wrote these slides when my husband was having bunion surgery. Researcher Bunyan has an outside consulting business, and he puts links on his MSU web page to his consulting business. Can he do that? Easy answer, no. Can he print business cards and stationery which prominently display MSU and his MSU job? No. Can he meet with his clients in his office at MSU? No. Can he occasionally use MSU's phone, computer, and internet access? Well, occasionally. Probably not too serious of a violation. Okay. I think I'll get rid of that one. Okay, it's the last one. Let's say that we have a researcher named Stone, and this Stone owns geologic imaging patents. And he developed these patents totally outside his work at MSU in a previous job, and they're his personal patents. Now he's going to make a proposal to NSF, and that research relates to that technology. Question is, can he use that patented technology as part of his NSF research? Can he? Well, who's going to decide what he's going to pay for it? Is he going to decide what he's going to pay for it, and what's he going to charge? If I were him, I'd charge a lot. Well, once again, he might be able to use it if it's clearly the best tool to use. But somebody else has to make that decision. He's biased. He has a conflict. He can't make that decision dispassionately. So while that may be the best technology in the world to use, it's something that it has to be determined independently from his bias. What if the research that he was doing could invalidate competitive geologic imaging tools? Well, clearly that'd have to be disclosed in his proposal to NSF. And that would be something that would require serious management to make sure that his interest in discrediting other technology didn't worm its way into his research results. So that's, I think, another good example of how a conflict can create problems in research. So that's all I had for conflicts. Any questions or comments on conflict of interest? Okay, thank you. Who's next? Oh, I'm next. Okay. Okay. I'm going to turn to another subject. Let's see. Okay. This is a difficult subject, so I hope you'll bear with me a little bit. Have any of you ever heard of export controls? Oh, good. Did I train you? Okay, well, at least a few of you know what export controls are, but probably most of you have never heard of it and you're wondering, what in the heck is she going to talk about? Well, if I had my notes, I'd know. Excuse me just a second. But export controls is another area that creates responsibilities for conduct by researchers that you need to be aware of. But let's talk about what it is. Export controls are laws that regulate distribution to foreign countries and foreign nationals certain technology, items, and information which is important to this country, to the United States, for security or for foreign policy reasons. So it's not technology or information that's classified and thus prohibited from being distributed. It's just information that's potentially damaging if it gets in the hands of certain foreign countries to the United States. So it's regulated. It's not prohibited, it's regulated through a licensing system. So you can only export certain technologies and information related to that technology if you first get a license to do that. So that's what we're talking about, this whole area. You still might be saying, so what does that have to do with MSU? We're not a manufacturer. We don't export things. We don't send things out of the country. What does that have to do with me? Well, it's more than you might think. Okay, now bear with me for a minute more. I'm going to give you a little more background on what is controlled. The things that are controlled fall really into three categories. One, things that are related to munitions, things that are related directly to weapon systems. And that includes not just the weapon systems themselves, but technology and services related to them. And then there are, the second area is things that are what we call dual use technology and items, things that are primarily used for civilian purposes, but can be used for weapons purposes. Examples of things that are militarily, ITAR, which is is the acronym we use, are things like satellite and radar. We do research on this campus that involves satellite and radar. And in the dual use area, on that list includes brucellosis, E. coli. We do research on brucellosis on this campus. We do research on E. coli on this campus. So it does have something to do with us. And the third area is that we may not do business with certain dreaded bad countries or certain dreaded bad people. And that can affect us too, because we have to be careful when we're working with other countries or if we're collaborating with people in other countries. Okay, so that's kind of how it relates to us. And if you have technology or information that is controlled, then as I said, you can't give it to foreign countries, and you cannot disclose it to foreign persons in this country. Well, what do we have on college campuses? How many people here are foreign persons? We have students, professors, all kinds of people who are foreign persons. And if this information that is controlled is disclosed to such persons, it's a violation of those laws. So that's why, finally I got to it, we have to be concerned about it. And we have to be concerned about it because look at all the ways you could disclose that. You could disclose it because you send a fax. You could have a telephone discussion with a person you didn't even know was a foreign person. And you could be discussing the research that you're doing. And you could have a violation and all of these other things as well. So if the research is controlled, then you have to worry about scientific collaboration with foreign nationals, using foreign nationals, including students, in the research itself, sending materials or goods to foreign countries, etc. And even making presentations at a conference where there might be foreign nationals. Okay, but here we get the good news. And the good news is that that universities have a special exemption, so that if you have an exemption, and what I'm going to reference particularly is that second one, the fundamental research exclusion, then you don't have to worry about it. So that's what you want. And the fundamental research exclusion or exemption is, even though you may have research that relates to satellites, radars, brucellosis, E. coli, as long as it's freely publishable and there are no restrictions on it from a security standpoint, then you don't have to worry about this. So that's why I and OSP work very hard to to make sure that we don't get restrictions like that in our contracts. And these things destroy the fundamental research exemption. But the fact is that we do a fair amount of research that's controlled on this campus. Any of you work in the physics department? The physics department has several controlled projects. They have several projects related to satellites which are controlled, which we could not get rid of the publication restrictions or the foreign national restrictions. And in those cases, the research had to be approved as being done at the university, and it required what's called a technology control plan. What a technology control plan does is it makes sure that nobody has access to that research who is a foreign person unless they have a license, which can be very hard to get, which we don't routinely get. You have to have physical security for that research. And as researchers, if you're doing that research, you would be responsible for that. You have to have very careful IT security, and Adam's going to talk about that. And you have to have training, and there has to be auditing and assessments. Okay. Even if you're not working on specifically known controlled research, you still have to be careful about sending items abroad, because even though you have an exemption for your research in this country, because you're a university, the fundamental research exemption, you still may not be able to send things out of the country. A lot of research equipment is nevertheless controlled, and you can't do that without a license. If you carry information abroad on your laptop and it's controlled, or it's related to any of those subjects, even though it may be subject to the fundamental research exemption in this country while it's here, you can't take it out of the country. You have to be careful of that. Another thing you have to be careful of is transactions with foreign countries. If you're doing material transfer agreements or shipping equipment to foreign countries, those things should be triggers for you to inquire more, maybe call me. So, and I'll just quickly tell you why you should be concerned about this. A couple of years ago, a professor named Reese Roth at the University of Tennessee was arrested for disclosing controlled technology that he was working on through a subcontract from the Department of Defense. And he included in his lab a Chinese foreign student and an Iranian foreign student. And he taught them how to use a particular piece of equipment that was controlled. And he also took controlled information on his laptop out of the country. And after a trial, this professor emeritus, who's 76 years old, was criminally convicted of violating these laws, and he was sentenced to several years in prison. And so the thing that is very concerning about these export control laws is that they're criminal, and they can really ruin careers. So if you are ever working on projects that are controlled, be really careful. So with that, I'm going to let Adam talk about the importance of IT security and data security.
Somebody want to show me how to advance the slides on this? Slides, advance. There's no keyboard here. I'm lost without a keyboard.
You can also use this and just go like that.
Okay. That I instill confidence in me that the IT guy can't figure out how to advance the slides. So I'm Adam Edelman. I'm the Chief Security Officer here, responsible for information security. And I know we're talking about export controls in this section, but I'm going to talk about something that of course, applies to you, things to think about if what you're doing does fall under these requirements, but also equally as important just in general for those of you who are handling information or using computers, which is probably most of us. Aside from the research data, is any of you doing teaching any courses, managing student information records, grades as a TA? There's some hands going up. So we do have the research data sensitivities to be concerned with, but we also have student records that we manage and other information that is sensitive or otherwise important. If it just went away, maybe it's not sensitive under federal law, but important to you. Other reasons that we're concerned with information security besides data have to do with just operationally. If you can't use your computer or the servers that you rely on, is that a problem or not? And probably is a problem. So I'm going to take just a couple of minutes to give you some things to think about to hopefully help you avoid either leaking any important information or losing important information or having problems with the machines that you're using. Anybody have any thoughts about what the biggest threat is to information security in general here? I'm going to try to make somebody speak. I know you've been quiet for a while. Anybody have any ideas to toss out? That's one idea. I'll try to speak up. My question was, anybody have any idea what the biggest threat to information security is? And I'll just go ahead and tell you, it may not be what you're thinking it is. It's all of us. It's user error. It's simple mistakes, actually, that cause the biggest problems and have caused problems for us here at MSU. The things you can do to avoid it are even simpler, though, so that's the good news. And we do have bad guys trying to hack into our network. We have other things that go on, but by far, the biggest source of problems we have are people putting information where they shouldn't be putting it, maybe not taking care of their computers as they should. And again, I'm going to give you a couple things to think about that will help you avoid that. Anybody here have any data to store or think they will in the research they're doing? Yeah, there's hands. And there's probably a lot more hands if you thought about it. Anybody keep important information on your laptops or your desktop computers or your little thumb drives, your USB drives, like these things? Yeah, hands. I'm not going to say don't do that, but I am going to say that by far your best option for storing any information that you need to make sure is available to you and also to make sure stays out of the wrong hands is to use a properly managed server. Many of you are probably in departments where you have local IT support, folks that run servers for your department. That's fine. There are also centrally managed servers that you can take advantage of. I'm not going to go into specifics, but at the end of this, I'm going to give you some contact information that you can talk to me or other people, and we can help guide you to make the right decision. But if you have important information, and in particular sensitive information, that data should not be stored on your little thumb drives or your laptops. Thumb drives fail, thumb drives get lost. Laptops fail, single hard drives fail, they get lost or stolen. Now, these are handy, and most of us probably use them. And sometimes, that's why I say I'm going to give you some contact information that you can speak to us about your requirements, but sometimes you might find that you really have to travel with information. Now, if it falls under export control, you can't leave the country with it, but you might need to keep it on a portable device for any number of reasons or a laptop. You don't need to know what encryption is, but there are options to encrypt that information, basically scramble it. And there are free options. Won't cost you anything, won't take you much time to use the utilities, but that's a really important step. There's a huge difference between somebody grabbing this thumb drive and plugging it in and getting a bunch of data versus somebody plugging it in and having it be encrypted. Now, can you crack encryption? Sure. If somebody can grab this and has the means to crack the encryption on this, they're getting our information some other way because it's not trivial. So, number one, if you have data to store, use a server, use a properly managed server either through your local IT staff or centrally through the IT center. If you have a particular need that may warrant storing information on a removable drive or a laptop, then use encryption. And again, we can help you with all that. We can help you look at what you need to do with your information and give you options on how best to handle it and step you through everything you need to know. How about sharing? Anybody here need to share information, whether it's even within your own lab or with other labs on campus or folks outside of the university? I see heads nodding. Sure, that's pretty typical. You think emails, I already gave you the answer. You think email is a good way to send information, in particular sensitive information? No, everybody's saying no, I hope. I'm going to talk a little bit about email in a minute, but that's certainly not appropriate. at all if you're in an area that would fall under the export control requirements, but it's not appropriate at all for anything sensitive. A few people have heard me say this: don't put anything in an email at all that you don't want to see in bold printed in your local newspaper, because email in general, and particularly here, is not intended for secure communications. Just like storing information, sharing information should be done on properly managed servers. Plenty of people say, well, I just turned on sharing on my desktop and open it up and let my other lab mates grab my data. Well, that happens all the time, and it's also a pretty big source of problems here. Again, I'm available, and as are others, to take a look at what it is you need to do with your information, how you need to store it, how you need to share it, and give you the best way to accomplish that, maintaining security, and probably actually doing it a lot easier than you may be doing it now, especially sharing things locally on a desktop. That's not the right way to do it, and there are better options, and we can help you with that. Any questions on either of those? Just take a minute to talk just in general about security. Online security, I mentioned email. It's not an appropriate means of communicating anything sensitive or confidential. It's not appropriate to communicate anything you don't want everyone else to read. And I have almost a weekly basis now, I see problems with email. I had one this morning where somebody inadvertently made a rather large personal email folder on their MSU mail, made it available for public viewing by accident. And it happened to have a bunch of banking information in it, which was their own information. They did it to themselves, but we found it by chance and helped the person clean it up. So things happen, mistakes happen with email. I've been on the receiving end of misaddressed email that happen to have sensitive information, and that's always a fun call. It's happened multiple times where I say, hi, I'm the security officer, and you sent me a message that had a bunch of bank routing information, and we need to not do that. What about phishing? Anybody not know what phishing with a PH is, where you get a message, and I think we all know by now that you're not going to get a part of $100 billion if you just give that person your bank account number, but you see some pretty good ones. You know, you may have just opened up an account with Wells Fargo, and then you get an email message and it's got Wells Fargo's logo and it looks really legitimate. You've probably heard it, but I'm going to say it anyway. There's no bank, there's no IT department, there's no entity anywhere that will ever ask you to confirm personal information online or through an email message, or to click on a link and just enter your password or your social security number. So be careful with email. If it doesn't quite look right, it isn't right. And if you haven't received a spam message or phishing message within the last 10 minutes, you're lucky, because it's really hard to filter some of that out. We do an okay job for central email, but it's an uphill battle, so you're going to receive those messages, as I'm sure all of you are used to seeing. If it doesn't seem right, pick up the phone or open up your browser. There's nothing wrong with banking online. Just open up the browser, go to the bank instead of clicking on any links, and be careful. Same thing goes with general web surfing. Be careful the sites you go to, the things you download. Common sense, really. If something doesn't seem right, ask. That's why I'm here, and that's why our help desk is here. And ask people if something doesn't seem right. What about social networking? Anybody do anything with Facebook or MySpace, anything like that? I won't tell you anyone else if you raise your hands. I mean, there's more in here than are nodding, I know. And there's nothing wrong with that, but it's something else to think about. Be careful what you put online. It could be as simple as something that might be embarrassing, which maybe isn't that big a deal, or worse, something that affects your ability to land a job or exposes you to identity theft. And things like Facebook make it really easy, especially when they keep changing their privacy settings unbeknownst to you, where information gets exposed. Just be careful with that, and I wanted to make sure I mentioned that. Desktop management, everybody here has got, I'm sure, a laptop or a desktop, whether it's a Windows PC or a Mac. There's some very simple things. I mentioned that the biggest threat we have are simple human errors. Well, it's even simpler to avoid them. Basic, simple things, plenty of people around here to help you to keep your machine safe, and it has to do with applying the updates as they're released from vendors, whether it's Windows operating system or your Mac operating system, your application updates as they're released. Very easy to do. Making sure you've got a firewall turned on. Firewall is just something that all the scans, all the connection attempts that come through our network, the firewall will basically keep your machine from answering them. Very easy to turn that on. And antivirus, anti-spyware, kind of cumulatively called anti-malware. MSU provides antivirus, no charge to departments for all faculty, students, and staff. We can help you with options on the anti-spyware. Very simple to do, the same thing you should do on all your machines, whether they're MSU machines or personal machines. That'll keep you from being that path of least resistance. Anybody here have more than one account at MSU? More than one username, password they have to manage? And maybe we're doing better, because that's usually a big challenge that we continue to try to help simplify that. But you probably have more than one account, whether it's for your email and for your banner, self-service work, and any other system. It's really important that you protect that username, password. Think of it as your bank account and PIN. There's never a need to share your username and password with anybody, no matter what they say. No IT technician is going to call you and say, I can fix your problem, just give me your password. So be careful with what you do with your credentials, your username and password. Make sure you choose a good, strong password that's not a dictionary word, and just some basic, simple practices. I think you all should have picked up this orange card, which has some tips on password management. That's an important point, and I'd urge you to read that. And really the most important thing, I know you've been listening to a lot probably all afternoon, is take advantage of the resources you have. Most of you probably are not IT experts and IT practitioners, but there are a few of those around campus, and that's our job, to help you decide how best to store information, how best to share information, how to manage your machines, what resources are available, where can you store sensitive information versus information that may not necessarily be sensitive, things like that. How do you turn on your firewall? That security guy said something about a firewall. You can get help, and this is just a few of the links that you should take advantage of. I think my name is in the contact sheet you all got, and if you can't figure out who to call, you can always call me, and if I can't answer the question, I can get you the right place. I put a couple of links that we're in the process of trying to improve the information we have on the IT Center's website. There's one link in here called Safe Computing, which will kind of guide you through some of those basics I told you about. If you like to do things on your own, you can go to that Safe Computing website. And I also wanted to put that final link in there on the policy and guideline having to do with data stewardship. That since the focus really of this had to do with data security, I wanted you to be aware of a current policy that MSU has on data security, and more importantly, the guidelines that may help you make decisions on what to do or not to do with your information. Any questions? That's kind of all I had, and I wanted to breeze through in the interest of keeping us ahead of schedule, but if you have any questions, I'm happy to answer them, or yes, in front.
I'm just kind of the data person. Do you know about how many emails come through our servers a day?
Several hundred thousand. The last I heard, something on the order of 97% of which are spam. Yeah. And that's pretty typical. So across the internet, well over 90%, 95, 97% is garbage email. So I'll let you know.
Do you know roughly how many attacks we get on our website?
Well, that's an interesting. The question was, how many attacks do we see on our network? Well, actually, it's kind of constant. There's things called port scans, which are sweeps through our network looking for, kind of rattling the door handle on everybody's computer, which is why I mentioned the firewall, but looking for services that may be running, looking for ways in, and a recent statistic was well over 100,000 port scans a day, and since there's 86,000 seconds in a day, it's basically constant. The vast majority of those are automated, part of botnets, which is another threat we have on the internet we can talk about offline if anybody wants to, but many of them are targeted. What happens is the automated scans come through and they say, I found 15 web, or probably 150 web servers, 10 database servers on that MSU campus. That gets fed back somewhere, and then the bad guys actually start manually attacking. And we see that constantly. And amazingly, or I shouldn't say amazingly, we do a pretty good job catching that and shutting those down before they're successful. Yeah. Any other questions? Okay. Thanks. Next.
Good afternoon. I know you've had a long afternoon. I'm Tamara Miller. I'm Dean of Libraries, and I bring you greetings from the faculty and staff at the library We're there to help you. I see some people who've even worked at the library out among you there. When I get trotted out to talk about the cheerful topics of plagiarism and copyright, I am almost always the least sexy item on the menu. Thank you, Adam, for making that not true today. So, why on earth should you care, and how do I advance my slides? The keyboard. Gotcha. Didn't see it. You may know that this building is brand new and that this is our premier lecture hall, so everything is new. Why should you care? I think that as users of the works of others, and more importantly as authors yourselves, you should care very much. All of the scholarship that you are going to work on is built on the work of others, so it's inevitable that you will come into conflict with issues of both plagiarism and copyright. So I'm going to quickly do a few basics so we're all talking about the same thing, and I'm going to give you the lesson first. And the lesson is that you should treat the works of others in the same way you would like your work to be treated. Very simple sort of golden rule. Plagiarism I'm going to do first because it's a lot easier. It's more clear-cut. Plagiarism is, as you can see, simply the unauthorized use of someone else's work without attribution. So, directly quoting from a source, summarizing another's work, and this can be inadvertent. Plagiarism is a matter of ethics and academic honesty. I'll say that again. It's a matter of ethics and academic honesty. So, in each of these examples, the thing that's important is that the original author be acknowledged for their work. It's also part of our academic misconduct code here, the student conduct code, and that does apply to graduate students, it applies to people involved in research. And there are many things in that code, bad things you should not do, among them plagiarism. And I think it's interesting that you might want to go and look at the full list. It's available online because it does have things like tampering with experiments or falsifying data that may apply more directly to the work that you're going to do here. I'm going to move fast. So avoiding plagiarism, there's really one rule. Cite your sources. And I would encourage you to begin immediately gathering enough information as you're doing your work so that you are able to cite your sources. Inadvertent plagiarism happens all the time. You read something, it becomes part of your mindset, you repeat it in a paper or an article, but you can't remember where you heard it. In fact, maybe it was so great you really incorporated it into your own work in a way that makes it difficult to cite. Cite your sources. Gather that information now, and then you'll be able to cite them. And when in doubt, if you're not sure that you ought to cite or not, cite your sources. And thus endeth my reading on plagiarism. As I said, it's very simple in my mind how to avoid plagiarism. Copyright, however, is a whole different matter. Because copyright is primarily a legal matter, you may not know, but this different kettle of fish is represented in the Constitution. And it is defined in great detail in a very complex set of laws. We're going to look at a little bit of it so that you'll just know why it's so difficult. So copyright is a form of protection that gives rights to authors. You will be such authors. So these will be your rights. You will have the exclusive right to copy, distribute, perform your own work. What is covered in copyright? Copyrightable expression is original authorship. I'm going to say that again, original authorship. Not somebody else's work you cite, your own work that is fixed in a tangible medium. Tangible medium could be film, it can be written, it can be any tangible medium. You cannot copyright unexpressed and unfixed ideas, only things that have been fixed. Do you know that works don't have to be registered with the Copyright Office in order to be covered by copyright? Copyright applies the minute you create it and fix it in that medium. Not everybody understands that. Now you do. And works don't need to be published to be covered by copyright. As soon as it's fixed in a tangible medium. So that brilliant idea that you had down at Molly Brown's and wrote down on a cocktail napkin and signed is covered by copyright. And so is everyone else's. And therein lies the difficulty, I think. So copyright infringement. We have a lot of trouble with copyright in the academic community because we thrive on the free exchange of information, but much of that information is, in fact, copyrighted. I would venture to say almost all of it is. So the unauthorized or prohibited use of someone else's copyrighted material is an infringement. What's a little scary about infringement, as you're making copies to hand out in class or other things that people do, what's a little scary is that both civil and criminal penalties may apply to copyright infringement. So that's serious. I'll give you a quote from one of my favorite people. Georgia Harper is general counsel at the University of Texas System, and she has devoted her life to making copyright understandable by academics. So she says, someone owns just about everything. Fair use lets you use their things, not as much as you'd like to. Sometimes you have to ask for permission, and sometimes you are the owner. So people might be asking you for permission. You will want to use copyrighted material every day, whether it's reading it at the library or whether it's incorporating someone else's work into work that you're doing. You'll want to cite, but you'll also want to be sure that you're making a fair use of that other person's work. So does this mean you always need written permission to use other people's work? Do you think it does? Not necessarily, and here's where copyright law gets a little bit difficult. Fair use. There are fair uses of copyrighted material that don't require permission or payment of royalty. But it's very hard to know what they are. The fair use law says, blah, blah, blah. One of the reasons that you can have a fair use for teaching, scholarship, and research. And then there are these 4 factors that have to be weighed. Okay, fair use is a non-infringing use, a use that doesn't require permission or payment of royalty. So great. As long as I'm at the university, my uses are fair. Not so much. The fair use factors I find personally vague and difficult. They are open to interpretation. They're not clear-cut. They don't say anything about what exactly you can and cannot do. But they do say that this is how you weigh the risk of whether something is infringing or not. So, the purpose of the use. Well, we are in good ground there, right? If it is an educational, not-for-profit use, it leans toward fair use. If the nature of the copyrighted work is factual as opposed to creative, that leans toward fair use. If the amount you're using is just a little bit and not the whole thing, and this gets tricky with images, because when you use images, you're almost always using the whole thing. And if you're not having any effect on the market for the item, you're not incorporating it in something commercial, you're not selling it separately, you're not putting it in a course pack and selling it to students, then it leans toward fair use. But all of this is just an assessment of the risk. There really isn't, it really doesn't tell you what you can do, does it? And I think therein lies our real difficulty. We want clear-cut guidelines of what we can do. And when those guidelines get set, they often get interpreted as the maximum. So we can put 1 chapter on electronic reserve. It was intended that you'd be able to put at least 1 chapter, but that's become a kind of cap. It's like the speed limit becoming the minimum or something. It's not what exactly was intended. I'm going to recommend something to you that Georgia Harper created. and it's called the Copyright Crash Course. It is University of Texas copyright guidance, so there is some University of Texas policy in there. But it gives a really good overview of what you can and cannot do with copyrighted material in an academic setting. Classroom copying, but more importantly, when you might have to seek permissions, when you might have to seek royalties, particularly if you include things in your own research results and so on. This is a really good online resource for you. I like it because it's written in English as opposed to legal stuff. Where you will encounter copyright personally, I think, is with regard to your theses and dissertations. So I'm going to assume that every one of you has a brilliant graduate career here, and you write a thesis or dissertation, or maybe both. And this will be a brilliant work in much demand, of course, groundbreaking. And it will probably be your first major publication, and you will need to deal with copyright. And here at MSU, you will be asked to sign over to the library permission to distribute that work as part of the requirement for your degree. Those works are now electronic, and we do serve them up off our server. So you'll give us permission, but you retain your own copyright. And the wording of the thing that is in the first page, the front matter of your thesis or dissertation, does say very clearly that you retain copyright, and that any commercial uses or extensive copying require your permission. So this is the time at which you become the person who will be giving permission. We do regularly and routinely refer people back to the authors of theses and dissertations for permission to use things out of those documents. Since they've gone electronic, the use, particularly of master's theses, has skyrocketed. What you write, what you create in your scholarship, becomes an important part of the scholarly record. You may not feel that way now, but it is absolutely true. And we end up talking to all of the people who've read your work and want very much to make use of it. In addition to retaining your own copyright, fixed at the very time that you create it, giving you exclusive rights, you might also want to consider something called a Creative Commons license. Creative Commons is an interesting movement, grassroots, that's gotten a lot of momentum in the academic community because it allows you to keep your copyright and allow others to use it for educational purposes. And you might want to visit this website, creativecommons.org, and see the various gradations. You can allow it to be used for anything as long as you are acknowledged, that is cited, cite your sources. You can also say, no, it can only be used for educational purposes but not changed. My original work has to stay original. And a variety of things that you're allowed to do as the author under Creative Commons licensing. But it gets your work out there, and a lot of people do a Creative Commons license to encourage more research in the area they're doing, to encourage the use of their original work. There may be other things you want to explore with the ways in which you manage your copyrights as an author. But I encourage you really to remember that you want to treat others' work the way you would like your work treated. There is something you will also do. In addition to your massive thesis, you will write articles. I know you will, and they will be successfully ushered through the peer review process, and they will end up in some of the best journals in your fields. And you will immediately be presented with a copyright form, and you will be asked to sign away every one of your rights in order to get it published. And many of you will do that. Many faculty do that. I urge you to read that document carefully. It might, in some cases, prevent you from using your own work in your own teaching in the future, or to put your own work up on your own website. If there are rights that you want to reserve to yourself, you ought to put those in that form, sign it, and send it back. Many publishers are increasingly willing to let you retain some of the basket of rights. Copyright's not just one right, but keep some of those basket of rights to yourself so that you can get the most out of your work and it draws people then to their journal and so on. So don't be afraid to negotiate with publishers about your rights as an author. I'm going to stop there and see what questions you have on this somewhat murky topic. All questioned out today, huh? Well, if you do end up having questions, I'm Tamara Miller, Dean of Libraries. Free to come by and see me, drop me an email. I live online, so I'm easily gotten by text, chat, IM, email, whatever your preferred way. But you might want to stop by the library and grab a cup of coffee. Brewed Awakening makes a great latte. Thank you.
Good afternoon. We're coming down the home stretch here. Just one more quick little presentation. So I'm Sandy Sward. I'm the director of the Office of Sponsored Programs, and this is Audrey Thurlow, and she's a program assistant in the pre-award office. So several of the presenters talked about a program called CITI, and that stands for Collaborative Institutional Training Initiative, or CITI. And we're going to show you how that will help you meet some of the criteria, the training criteria if you're going to be working with animals, if you are going to be working with human subjects, etc. So we're going to get started here and show you that there are a couple of ways that you can get to the website. It's a subscription-based website, and MSU has paid for a subscription to that site. So from the homepage, you can go to the research link. And from the research link on the left-hand side, there's a link called Research Compliance. And then over to the right, it says CITI Online Responsible Conduct of Research course. So click on that. And technology is working for us. It's one of the scary things when you decide to go online and do a demonstration like this. But first of all, this is a place where you can go to find coursework, not only to help if you are going to be doing that type of research, but now many instructors are also requiring this as coursework. And we know that because we get a report of all the people that have completed coursework on the CITI site. So once you're at the home page, you want to scroll down to where it says New Users Register Here. Once you're on that page, what you want to do is make sure that you affiliate yourself with a participating institution. So Montana State is one of the institutions, as I mentioned, that has a subscription to this service. And it's important that you pick Montana State University because then you will get credit for completing those courses, or students who use it will get credit for completing the various modules. So then it's just like any other website where you're going to scroll down and you're going to put in a username, you're going to pick a password for yourself, and you can call Adam and get one that's really encrypted if you want. Scroll down, put in your name, put in your preferred email address, and it will ask you if you want to participate in the survey at the very bottom or if you want some continuing education credits. We're going to skip this part because we don't want to create a new user for this, and we're going to log in as me. So this website has quite an interesting software behind it that once you answer some questions about what areas of research you're interested in, it kind of compiles the modules for you that it makes available that we have subscribed to. So you can see now it recognizes this as me. You can also look and see what I have completed or not completed. You can go part of the way and stop. If you get interrupted, then you can re-log in and finish that particular module. So one of the things, too, that's great about this is it has learner groups, and so it keeps track of what those various areas of interest and research are. So why don't we click on that? So this is what Mike Babcock and Chris O'Rourke were talking about, the lab animal welfare courses that are on here. And each time you go into one of these modules, you're going to have to sign an integrity assurance that says, yep, I'm Sandy Sward, and I'm actually doing this work, and I'm the one that's going to complete this particular module and the work associated with it. Each of the modules that you get into typically has an introduction, a background about that particular area. It also will have a case study, like Pam covered some case studies, discussion topics. Sometimes they have little videos or little vignettes that are in there. And most of them have a quiz at the end. So once you take that quiz, it will prompt you then that you have completed that particular course, and you get a completion certificate. And so we recommend that you print that completion certificate, but we also get an email that you have completed that particular module. So did I miss anything there? It actually is very simple to do. If you have trouble once you get into it and something isn't working quite right, give us a call. Our contact information is on the handout. And if you happen to lose your completion certificate, give us a call, because we also can print up a report that shows that you did the coursework on it.
Do you want to go into each one?
So we can just give you a quick look at when you go in. I think you want to do the re-enter one. So there's the integrity assurance statement that you'll have to prove that you are the person that's doing that particular work. But if you go into each module, it will show you, if you scroll down, these are all of the modules out there that MSU has subscribed to. So there are quite a few covering social sciences, animals, human subjects, data integrity, all of those sorts of things. And the grade book that's down at the bottom, the middle hot link there, shows you how you scored on each one of those courses. You can take them again if you wish to get a better test score. And then you can always go back to the main menu and go from there. So any questions on that? You guys have been a great audience. I really appreciate all of your time and for attending today. Our office is on the top floor of Montana Hall, and we're there to help you. So please give us a call if you have any questions. Thank you.
So just wanted to thank everyone once again for attending today. We'll keep track of the sign-up sheet, and if you don't have time or want to spend the time now to complete the evaluation form, drop those in the office in an inter-office envelope to the Office of Sponsored Programs. And thanks everybody for making this a great session.